Welcome to my talk. I'm happy to be here. I think it's my third time at Voxed Bucharest, and I always have a pleasure to be here. Hopefully, next time it's going to be in person. Anyway, here's my talk, from Flatland to Spaceland. Many of you may wonder where does this title come from. So it's kind of a paraphrase of the book by Edwin Abbott from the 19th century, where it tells a story about the creatures that live in the flatland, and all the creatures were like squares, triangles, octagons, etc. And they lived in this 2D world all the time. And one day, a creature from the 3D world visited their world, and that was a sphere. And the only thing that the creatures from the 2D world, from the flatland, saw was kind of the intersection of the flat plane and the sphere. So that was basically a circle, which was getting smaller and bigger as the sphere was intersecting the flat world. And all the creatures in the flat world, they didn't know what they're dealing with. This interaction with this new creature was kind of new for them. And I like this comparison to what is happening right now, because all of our lives, whenever we interact with computers, with digital assets, every single time we use 2D projections of anything, because we are interacting with 2D screens, be it the computer screen or the mobile device screen, which we touch. Whatever we're using the 2D screen and the projection of whatever to this 2D space. And the thing is that it's changing right now. So the paradigm is kind of shifting. And with this talk, I would like to show you where it's headed. Where are we right now? What tools do we have at hand as developers? And what is being available so that we can start work on it or play with it. Few words about myself. I'm Rafal. You can find me on the internet by the name of Rafek. I work as a mixed reality developer at Avenga in Poland. I'm also a Microsoft MVP in mixed reality, and also I co-organize a conference in Poland called DevConf. Okay, so let's deal with the basics at the very beginning, because since 2017, as far as I remember, I talk on conferences about those topics, mixed reality, virtual reality, augmented reality, and most of them are software development conferences. So I deal with like tech-savvy people. And what strikes me the most is that many people doesn't differentiate between VR and AR. Sometimes they tell something and they mean VR, but they say AR, and vice versa. So because for some people it kind of feels interchangeable, but it is not. So what I usually do is I do have this one slide where I explain basic differences. So let's start with VR. VR is virtual reality. That's what it stands for. And basically, that's an experience where you put a headset on, and well, I have one of those. So like this one. So you put it on the head, and you can't see anything else. Like the whole physical world is actually occluded, so you can't see anything in the real world. But then you see everything that is artificial. It's rendered by the applications that you're running, and your mind is tricked into thinking that the real world doesn't exist and you're only in this virtual world, and that's the whole thing, right? And well, you can sometimes see those funny movies on the on the internet where someone is playing a VR game, and then all of a sudden someone, for example, pokes that person, and that person doesn't know what's happening, because well, that person's mind was somewhere else in this virtual world. It's pretty amazing how it works. It's very immersive. And on the other hand, we have augmented reality, which could run nowadays on either mobile phones, smartphones, or different kinds of headsets. And augmented reality is basically our physical reality with an additional layer of digital assets. So we use a device, be it a smartphone, tablet, or the augmented reality glasses, and then by looking through them, we see the real world, and then on top of it, we see some rendered stuff, whatever, depending on the application. When it comes to mobile phones, obviously, we look at the screen, and what we see is the live feed from the camera of our surroundings, and then on top of it, there are things being rendered. Okay, and the plan for this talk is to go through all the maybe main things that are happening in the industry, AR, VR industry, and to show you that the hype is real, that those things are actually happening. I would like to show you that all the big companies, tech companies, are actually investing lots of money and time and effort into developing something AR, VR. And let's start with Facebook. Well, it's not Facebook anymore. It's called Meta right now. And right now it's kind of obvious with its name that they're very into metaverse, augmented reality, and virtual reality because, well, they changed their name to reflect that. But not that long ago, not like long time ago, it wasn't that obvious. But Facebook, a few years ago, they acquired Oculus, which was the leading, and still is, a leading vendor of the VR headsets, right? And what they did is, well, they iterated on it, and as a result, we have Oculus Quest 2, the newest one of their headsets, which is pretty impressive. And also, what they announced, like pre-pandemic, as far as I remember, is that they are indeed building AR glasses. So they are very into it. And to show you some more, some example, so that you know what I'm talking about, I'm gonna show you a video. One second, I need to be sure that you see that. Okay, so that's Oculus Quest, right? Actually, the one that we are seeing on this video is the first version, but what they do is they keep releasing software updates like all the time, like basically every single month there's a software update. And as you can see, for example, here, by only a software update, they unlocked the hand interaction. So you can wear a VR headset and then use your hands that are being tracked to interact with well, anything that is digital and interactable within the experience. The other thing that they work on is, well, because of the headset has all the 4 cameras here, as you can see, we can stream a video feed from the camera to the goggles, and then on top of that video feed, we can render 3D content, and that's called pass-through AR, right? So this is an experimental mode, so it's black and white right now so far, but that proves the concept that we can see the video feed and then render on top of it. And we have AR experience within a VR headset. And that also was unlocked with the software update. Also, just to show you some more features, like they work on Infinite Office, for example, so that they can bring real things into the VR experience and then set up your desk the way you'd like it to be, like multiple screens, etc., and use your physical keyboard.
Oculus state that they'll be supporting more keyboards in the future. But I've got one of these Logitech keyboards on order, so as soon as it arrives, I'll test it out and share with you how well it works.
Just imagine having this kind of office and work within it, and set up it the way you like. Okay, so that's Facebook or Meta when it comes to hardware. The other vendor is Microsoft. So they started with this technology a long time ago, actually. If you remember Kinect in 2010, as far as I remember, it was, in the times of Xbox 360. It was kind of a beginning of this technology. It tracked the user movement, and then with those movements, you could extend the game, and you yourself, you were the controller, and they iterated upon this technology, and then in 2016 they released a HoloLens 1 and then HoloLens 2. Actually, I have those devices with me, and I can quickly show you them. So this is HoloLens 1, and what you can see is that it's a headset, so you can put it on your head, and you see everything that is around you, because this is basically an optical display, like pass through, so you can see everything. And then on top of everything that you see, the apps, they render digital stuff. And a few years later, HoloLens 2 arrived to the market, and that's yet another iteration of this product, which is just more solid and more powerful, and have like better field of view and hand interaction and eye interaction as well. And what Microsoft did with this device is they aimed at enterprises, so that companies, they can start thinking about solving their problems with those kind of headsets, so that software could be written to support the line of business. So this device is not aimed to the consumer market, because, well, it costs $3,500, but it perfectly fits the enterprise market. And it's actually happening. I can see more and more companies that are being created that solely develop applications for HoloLens, for example. And to show you capabilities of it, I would like to show you a video that shows features of mixed reality toolkit. It's a toolkit for that contains building blocks for mixed reality. Namely, well, that's an extension for the Unity. That's the software where you build mixed reality experiences in, and it allows for quick prototyping and building larger applications as well for mixed reality. And it's also cross-platform, so that you can target not only HoloLens, but, for example, Meta Quest or mobile devices as well. But this video would show what exactly is possible. So as you can see your surroundings, you can see floors, ceilings, etc. And on top of it, we can have 3D objects, right? And we can interact with them with your eye, with your hand, with voice, etc. And it works pretty smooth. At the moment, I think it's the best experience you can get when it comes to AR and the headset. And there are some other ones but it's not like they're supported by so big community, I would say, and the company behind it. Last interesting feature would be, hold on, I'm just going to show you the eye supported pan and zoom, for example, or auto eye scroll. So whenever you look, then that's where the focus goes. So for example, you can read the text and it would automatically scroll as you reach the end of the text. So that's pretty much it. It's actually easy to start to develop for this platform because the documentation on the Microsoft side is pretty extensive and it's being updated all the time. And you don't even need the device itself because all the simulators and emulators are available, and you can do like 90% of the job done within those simulators, which is pretty impressive. And it's very easy to kind of start working on it if you're a just regular developer. It's just C# and Unity, and to prototype quickly different solutions. Next up is Apple. Well, they do not have any headsets at hand, but of course there are rumors that they do work on some. They're expected to be delivered in 2023, 2024, but well, you never know because those are rumors after all. But after seeing what Apple is into and what they deliver with like the latest iPhones and the software that they're delivering, it's fairly easy to assume that they're into augmented reality as well. Um, well, because for example, they have tools like ARKit, Reality Composer, Object Converter. Like all those tools make um, creating AR experiences very easy and smooth, and they could be delivered to iPhones, like newer iPhones, I would say. And for example, if you would look at like iPhone 12 and 13, from the Pro version, they included LiDAR sensor, which basically is one of the best things to get depth from the scene. So to show you what's possible with Apple, there's a quick video with possibilities of ARKit. I think that video is from ARKit version 3. But what you can see, that's the real person walking within the living room, and those figures are virtual. And as you can see, for example, virtual things can occlude real person, and the real person can occlude virtual things. So that's the whole experience is very immersive. Also, we have like body motion tracking.
To his left, a blank augmented reality model with ball and socket joints mimics his movements. The man smiles as he lifts his right hand to the sky, his left hand extended down.
And also we have things like shadows. So we have here like the real table and virtual things rendered. And then you can see like virtual things can interact with the table, can fall from the table. And then we have like ambient lighting and shadows so that the immersion is real. We really can be tricked into thinking that those objects, those virtual objects, are actually part of our surrounding. So all of that could let us thinking that Apple is into it. The only piece missing here is obviously the glasses itself, so that it could be even more immersive. But they're working on this technology apparently. And the last one, but not least, is the Google. Google have they did started the earliest, I would say, because in 2010 they released Google Glasses, which was kind of a misunderstanding back then because they hyped that product very much, but kind of the world wasn't ready for this kind of experience yet. We didn't have technology that was able to tackle those issues, and it kind of died pretty quickly. But it showed its interest, Google's interest in it. But then they iterated upon their ideas, and right now what we have from Google is AR Core, which is basically a very similar thing that Apple has for iPhones. which is a toolkit that is that helps us creating, allows us creating things, AR for Android phones. So that's pretty much it. And obviously, well, there are multiple other companies, smaller and bigger on the market, that produce some kind of glasses or AR experiences. Some of them are like very specialized glasses um, for doing like one thing, right? Or the other ones like HoloLens, which are for like more purposes. And to show you an example of one of them is, for example, Magic Leap, which is kind of a biggest competitor of HoloLens, I guess, right now. Recently, they released a video showing the newest part of their glasses. That's the second iteration. So, for example, the difference between this Magic Leap 2, Magic Leap, and HoloLens is that HoloLens is the headset and it has everything in itself, meaning the computing unit is also built in within the headset. But in this case, the approach is different. The computing unit is the separate device connected with the cable to the headset, and that device is, well, you can just snap it to your belt or put it in your pocket. So that's pretty much it. And there are other companies that I think they think a little bit more about it, and they're trying to push the boundaries even more, and they are thinking about creating a contact lenses for augmented reality. And actually, if you Google that, there are some big companies that are investing in it as well, like Samsung, for example. But to show you an example, that's one of the startups, which is called Mojo Lens, that creates a prototype of the contact lens that is capable of doing AR and VR, depending on whether you're closing your eyes or not.
Could we see differently, more clearly? Could it help us find that invisible edge when we need it most? Or allow us to connect in crucial moments, providing vital information in an instant? Introducing Mojo Lens, the world's first augmented reality smart contact lens. Put Mojo Lens on in the morning, and throughout your day, you'll have access to timely information without losing focus on the world around you. Mojo Lens is designed not to bombard you with data, but to elevate your vision by providing the information you need exactly when it's needed, all while letting you look like yourself. When it's not in use, the technology just fades away. We call this concept invisible computing.
Mojo's invisible computing solution will be a platform that gives you everyday superpowers and an invisible edge throughout your day. But before it does any of that, it first has to be a great contact lens that improves your natural vision even when it's off. Mojo Lens built-in display will give you augmented reality wherever you look. It even works with your eyes closed, putting you into an instant VR world.
The applications are nearly limitless, from being able to see in the dark or low light situations, to augmenting your memory with instant information, showing you real-time translations, or giving you a virtual teleprompter. One of our first medical applications is using AR overlays, like edge detection and contrast enhancements, to help people with vision impairments such as glaucoma and macular degeneration.
So it does even have like the display, the sensors, and the batteries.
The Mojo Lens includes
So that's pretty impressive.
batteries to power the system, as well as motion sensors to enable.
So it doesn't mean we have like we would have this in the market in like 1 year or something like that, but that shows us the interest, right? Some of the companies are doing things that are actually possible to ship and to leverage right now, and the other ones are pushing the boundaries even further. Okay, that's pretty much it. And the interesting part here is, I mean, when it comes to developers, for example, is that the market share, the possible market share for VR and AR applications is pretty large. Okay, so when the consumer part of this diagram is pretty obvious because that's video games and video entertainment. The other part is also interesting, or even more interesting from the developer's perspective, because that opens for these applications, VR and AR, the whole new sector. And more companies from industries like healthcare, manufacturing, engineering, real estate, they keep asking for solutions in VR and AR that could work with the line of business, right? And that's where the big money is. So that's the big opportunity for developers to switch or to develop those kind of skills where we could deliver those kind of applications. Right now, as a segue to the another part of the presentation, I would like to show you the brief history of computing and digital transformations. So at the very beginning, when we were given personal computers a long time ago, there was this first digital transformation, meaning we didn't have computers, personal computers, and then all of a sudden we do have access to them. So what we started to do as people, we started digitalizing things. We started putting things from paper to computers. And then there came second digital transformations with GUIs and the internet. So that personal computers and the systems, they became even more accessible for more people because, well, we have those graphical user interfaces and like mouse and interactions with it. And then the internet, which allows us to share whatever we digitalized with the world. And then there came third digital transformations with social media and smartphones. And this transformation is probably the one that we all remember pretty clearly. That unlocked us like all the collaborative scenarios with other people, so that we could become content creators pretty easily with just our smartphone and the connection to the internet and social media. That changed a lot. As we all remember, times before smartphones and social media, it was pretty different. And then what's happening right now with all the technologies like edge computing, mixed reality, wearables, blockchain, AI, 5G, it seems that we are at the very verge of another digital transformations, which is called by some as fourth digital transformation. And it's about like new computing platform being created so that we would move from smartphones and social media to something more. But before we would get there, we need to solve one issue. Like, just imagine that the augmented reality experiences and VR experiences right now, they feel like websites on the internet in the 90s. I mean, we had a bunch of websites here and there, but they weren't kind of connected. They weren't dynamic. It was like all static informations. There wasn't like there weren't possibilities to interact with them or with other people, to create the content dynamically or to collaborate with others. That started changing later on with Web 2.0. And the same is happening to augmented reality right now. We have a bunch of experiences here and there. We can download some apps, etc. But it's only us. We're kind of by ourselves within it. So to change it, we need to create this virtual world or the parallel world where we would all connect with those applications. And that's where the term of metaverse, mirror world, AR cloud, digital twin comes into play. We need to create this digital twin of Earth or of the locations we're in, so that whenever I use my augmented reality within that location, I can see what others are doing within that location and interact with it as well. So imagine like playing an augmented reality game in your backyard or in the town square in your city, and then you can join someone other that's playing in the same spot, right? You can join that person's experience, for example. So some people name it a spatial web, and the difference is that as the World Wide Web was websites that were linked together, the spatial web is basically everything linked together: spaces, people, assets, etc. So we live in our physical world, and also in the parallel world that is kind of layered on top of it. And then to achieve it, I would like to show you that all the companies that I've just shown you with the hardware, they also are investing into creating some sort of metaverse. And of course, the first company, Facebook or Meta, they're very invested into it. They want to create metaverse, whatever that means for them. But even if they kind of so they kind of stole this metaverse name, and they try to create this virtual world, like not augmented reality world, but the virtual reality world, where like everything is included. You need to have this kind of headset to interact with it. You kind of you leave the physical world and go into other world. Just don't be misled with that, because they kind of stole that word, and like everyone thinks that it's going to be bad because it's Facebook, and like all the bad things will happen with that. The overall term for metaverse, mirror world, etc., is that basically we create something in parallel to our world, so that we can draw on it with digital assets. And for example, one of the approaches of Facebook or Meta is to create life maps. That's
To achieve
basically
this, Live Maps uses machine perception to create
okay.
multi-layer representations of the world, showing where you are in space, recognizing what things look like.
So that's basically about mapping the real world in the real time.
Connected devices like
With the
smartphones,
devices.
glasses, or scan the surroundings to create a live
No matter what
dynamic
devices we're meaning here.
amplified by crowdsourced data, allowing the maps to recognize when things have changed and update automatically.
So if we would have this parallel world or spatial web constantly updated with data from like millions of devices around the world, we would have this accurate map of everything in the cloud, and so that we can live 3D things here and there, or 3D apps, etc., so that everyone could interact with those apps. So imagine like and on the factory floor, for example, you can have like all the machines that are laid on the floor, and then if you approach that machine, you could have a 3D dashboard that is getting data from some kind of backend and is being displayed in like floating in the air next to this piece of machinery. So that's what it is for example. And Facebook, to achieve that, they told that they released some kind of glasses, but that's only a research project, and they gave it away to its workers, employees, and contractors, and they work on gathering data from here and there, and they're gonna see what they can do with that, right? Those glasses are like for research purposes only. They only have sensors. They don't have any display, so that's only like simple glass here. Next up is Microsoft. So Microsoft approached it from a different angle. So they're not mapping like the whole world, but they're giving us tools based on Azure that allows us to leave things in the physical space, like leave visual things into physical space. So basically we can, within our AR experience, we can designate a spot somewhere on the floor, on the wall, anywhere in the physical world, and the app would take care of remembering that physical spot. And based on that point that we designated, it would build a point cloud that you can see on the half of the screen, and that point cloud would be stored within Azure for later use and match. So whenever we would approach that point in the future, or someone else would approach that point in the future, if that would match with whatever is being stored in Azure, we would be able to recreate that point. So that unlocks us all the scenarios where basically we can leave 3D content anywhere in the physical world, right? And that's all secure because, well, you could have questions like, hey, does this application or the hardware like send a video feed of the surroundings to the cloud and it stores it there? That is it secure? It is, because it's not it does not upload any like visual feeds, like no photos, no videos. It all computes it on the device itself, and whatever goes to the cloud is basically like point cloud, right? And it works like this. It's called Azure Spatial Anchors, and that's a service on Microsoft Azure. So with one experience, we can scan the table, for example, as we can see here. We can place something, and by running the same app on other device, we can match that place, and based on the information in the cloud, we can recreate it. Of course, that would the whole process would be invisible to the user. It would just basically appear like we are in the place where we were supposed to see something, and then it would just appear. We can leave 3D things for later. Just imagine creating, for example, like a city game where you would leave 3D content around the city and then let your user find it with a phone or some sort of glasses in the future. So it's there, it's available. You can actually go to Azure, sign up, and use it. Next up is Apple. And what they're doing is very similar to Microsoft's Azure Spatial Anchors, and it's called location anchors. And what they do is, well, basically they allow for the similar thing that Azure Spatial Anchors, but it's only available in like big cities in States and I think London in Europe. And it unlocks scenarios like this,
from the scavenger
like what
application.
I just
They're
mentioned.
using
For
the
example,
Location Anchors API.
the
Scavenger hosts
city
AI
game
content at
map.
real-world locations.
The
It
city
enables
game
the
app.
creation of virtual public art
So
installations
you can
and
leave
activities. It's a good example of how
3D
location
stuff
anchors
around
empower
cities,
outdoor
like in
experiences
San
as the
Francisco in
world
this case.
reopens. The Maps app is also introducing a new AR feature that uses the API in iOS 15. Let's take a look. This here, Maps is adding turn-by-turn walking directions shown in AR using the Location Anchors API. They incorporate several practices we recommend.
And then there's Google, and based on what they managed to gather when it comes to data about our world, I think they have the best data set so far, because with the Street View data, they basically have the digital twin of our world because they photographed everything. Based on those data, they have visual positioning system, which basically, whenever we use our phone, right, we can, whatever the phone sees, the surroundings, it could be matched with whatever is being stored within the cloud, right, Google Cloud. And then based on that, we can identify where the user is. So it's more accurate than the GPS itself, because within crowded cities or cities which are like very dense with the streets, like streets next to the street, the GPS is not that accurate. But with visual positioning system, we can actually pinpoint things with a better accuracy than GPS. And for example, they incorporated that technology within Google Maps on mobiles, because if you would launch the navigation to some destination, and then turn on the walking functionality, you could enable the AR view, so that all the like signs, arrows, etc., they're being displayed in this world near you. So imagine having glasses for this, and all of a sudden we live in this, also in this parallel world with all the 3D layer on top of the physical world. And of course, there are like bunch of startups and smaller, bigger companies, same as with the hardware, that they work on their approaches to creating mirror world or metaverse. Some of them companies were already acquired by bigger ones like Apple or Microsoft or Niantic, for example, and that only proves that they're all into something. And then there are associations and other foundations that they want to standardize whatever is happening with the AR cloud or metaverse right now, because as you can see, like many companies are invested into it, and everyone is going to push their own technology into some direction. But it would be good to have some kind of standard on top of it, so that we could interact with everything, and so that we can be sure that it's, for example, safe and secure, etc. So it's also happening as well. And well, based on all of this, we could see the science fiction movies happening in front of our eyes right now, aren't we? So we could basically start right now as developers and leverage those technologies that I've just shown you to deliver 3D content within our physical world. And it's pretty easy. And with iPhones, for example, we have like millions of AR-enabled devices out there in the world, so that you can deliver apps to the users right now, tomorrow even. And my aim here, or what my suggestion is, so whoever is interested in like developing those kind of applications, it's a very good moment to start doing it, because as you can see, we are at the very verge of like bigger things happening, because like it's happening in several different places, like several different companies. So sooner or later, there will be a product that will hit mainstream, and that's where magic will start happening with this technology. For all of us that, for all of you that you are interested into getting more from the subject, those are 3 books that inspired me the most, and they tell about the transformation that is happening right now, or our approaches to the transformation, or what kind of other augmentations could we approach when it comes to augmenting our lives. That's pretty much it. That's the place where I usually ask for questions